exploring consensus mechanisms, a cryptography and blockchain security perspective.
Welcome to the Universal Principles podcast. Today we're diving into consensus mechanisms. Simply put, how do we agree on things when we don't necessarily trust each other? It sounds like a political thriller, but it's actually fundamental to how blockchain works. We have a special guest to help us unpack this. Welcome.
Thanks for having me. What's fascinating about consensus mechanisms in the context of cryptography and blockchain security is that they solve the Byzantine general's problem. How can a group of agents coordinate an action when some may be faulty or malicious? It's about achieving a single source of truth in a distributed, trustless environment.
So it's like a digital version of making sure everyone's on the same page, even if some people are trying to tear out pages of the book. Could you elaborate on the higher concept of these mechanisms?
Absolutely. At a higher level, consensus mechanisms are agreement protocols for distributed systems. They're relevant in any decision-making process where you need to ensure validity and prevent manipulation. This extends beyond blockchain to things like voting systems, resource allocation in cloud computing, and even conflict resolution in international relations.
That's quite a scope. Okay, let's get concrete. Blockchain uses things like proof of work and proof of stake. What are those and why are they so important?
Proof of work POW, like Bitcoin uses, involves miners solving complex computational puzzles to validate transactions and add new blocks to the blockchain. The first to solve the puzzle gets to propose the next block. It's energy-intensive but provides strong security. Proof of stake POS, on the other hand, selects validators based on the amount of cryptocurrency they stake or hold. It's less energy-intensive but has different security trade-offs.
So one's like a digital lottery where you need a powerful computer, and the other is like owning enough shares to influence a company's decisions.
Exactly, and each has its pros and cons. POW is very secure but uses a lot of electricity. POS is more energy efficient but can be more vulnerable to certain types of attacks if not implemented carefully. Consider Cardano or Solana, for instance, who use proof of stake.
Interesting, thinking outside of blockchain, does this idea of reaching agreement in a distributed setting show up anywhere else?
Definitely. Think about decentralized consensus in organizational management. Large companies can use similar mechanisms to ensure all departments are aligned on strategic decisions, even when there are conflicting priorities. It's about creating a system where everyone has a voice and the final decision reflects the collective will, or at least, a well-vetted compromise.
So instead of miners solving puzzles, it's departments presenting their data and arguing their case. Makes sense. What practical advice would you give to someone looking to implement consensus mechanisms, whether in blockchain or another field?
First, clearly define the goals of the consensus. What are you trying to achieve? Second, understand the trade-offs between different mechanisms. Security, efficiency, and scalability often compete. Third, thoroughly test and simulate the system before deploying it in a live environment. Bugs in consensus mechanisms can be catastrophic.
Great advice, so define the goal, weigh the trade-offs, and test. This has been fascinating. Any final thoughts for our listeners on the power of consensus mechanisms?
Consensus mechanisms are more than just technical protocols. They're about building trust and coordination in a decentralized world. Understanding their principles can help us design more robust and equitable systems, whether in technology, governance, or even everyday life.
That's a brilliant note to end on. Thanks for joining us on Universal Principles, and to our listeners, keep exploring the principles that shape our world. Until next time.